跟你们嘛，我们今天会录影，那所以等一下同学有没有发纸给大家写？你们可以拍照，你们也可以写一下重点。好，那影片我们也会放上去，可是我不知道今天有没有办法可以放得上去。然后明天我们是有一个算是补课嘛，那也是一个 AI 国际赛，那院长会来下来，会回先生听见。好，那有报名的，记得一定要签到，因为那个面包餐盒也是杨玉娇大叔的，就是跟国际电机电子公司是学会。如果你没有报名，那可能我们就没有办法。就你要有报名，因为那个名单是要给 ICPO 的国际电机电子公司，没有我们就要自行处理。好像有20几个报名，那是不是？好像我们的统计全部有80几个，对，有20几个报名，那可能还有20-30个没有报名的。没有报名中，就要自己处理，或者是你们就对，我们就没有办法。那个在哪一间教室，应该学长都。癌症的问题，有声音吗？有的，有哈。那个俊奎确定有声音？
他那边不要讲话。
好，那我们就等一下，记得同学要做笔记，要做笔记。如果不懂都可以举手。好，那老师或者是师母在后面都可以帮你集体做翻译。好，就是我们就可以集体帮大家做翻译。好，师母坐在后面那边。好，那或者是学长应该也都可以翻译，因为这个我们都听过好几次了，就是至少听过10次以上。因为这疫情前我们就已经在世界各国推广了。那疫情过了，现在又可以出国了，好，所以国际移动能力很重要，好，就是在地球小小的，能够到地球的不同地方去是很重要的。OK, so please, thank you.
Thank you very much. 你好，你好。Thank you very much for your kind introduction. I don't know, but I think that he explained what I'm doing and what is my position or in society or something there. Yeah, maybe he said some good things, but I'm not such a good person. So, and also I'm just ordinary professor. Come from the Osaka Metropolitan University. Yeah, you know Osaka, right?
大阪
And I'm working on the algorithm design, and my research is about developing the algorithm. So I don't have many applications. I don't have many fancy applications. So maybe you are not so interested, but you will know some basic of computer intelligence, part of the computer intelligence. Today's topic is evolutionary machine learning. So first of all, I would like to ask you, how much do you know these topics? So in this lecture, I will teach you the evolutionary machine learning. But this is the name indicates this is a hybridization of machine learning and evolutionary computation. So let me ask, how much do you know about the machine learning? If you know the machine learning very well, please raise your hand like this. If you know the name,
知道机器学说的地方
please raise your hand like this.
好，应该有同学知道吧？好，
If you don't know at all, please down like this. So maybe some of you. How about the evolutionary computation?
演化是
if
基本。
you know the evolution computation very well, please raise your hand like this.
如果你知道演化是基本，像 BSO 啊、GA 你们用过吗？如果你知道就举手。
If you know
今天早上
some
上
name, please raise your hand like this.
都不知道。有，那你要举高一点啊。
Please don't
知道一点点。
but maybe you don't know.
It's my fault. It's my fault because my student, Junhan just teach the student about the evolution computation, but maybe they can understand well. So maybe later you can deal with it.
Okay. So in that case, you use the score, credit for this course. It's okay. But you know about at least you really know the concept of the evolution computation. Then later you will know the maybe you will understand something about the evolution machine learning. It is very exciting result here. So let me briefly explain the machine learning, evolution computation, then evolution machine learning. All right. I have to check the time. Don't know how much I need to explain all the things. Anyway, let's start. So this indicates the overview of machine learning. The machine learning is a generic term for technology that enable computer to acquire human learning ability. And these are the typical type of learning. The supervised learning, reinforcement learning, unsupervised learning, and the semi-supervised learning. Right? So yeah, you know something about that. No. Yeah, it's okay. No problem.
So I explain in Chinese, okay?
It's okay. Yeah.
第一个是监督式学习第二个是强化学习跟增强式学习 reinforcement learning 有没有？你老师不是白板上写过？第三个是非监督式学习。监督式学习就像一个老师你在考卷的时候，你去教老师，那学生在做作业的时候，你就看你这个错了，要怎么改？那非监督式学习就是没有，监督式学习就像 open book 这样你就是可以去开书考试嘛。那非监督式学习就是都没有的。那 semi super 的learning就是一般。那等一下。那个Nojima老师他会讲一些基本的概念，这样对吧 ？OK。
Yeah, maybe you can explain.
I explain in Chinese because I think maybe the English will be enough for the speaker.
Maybe not. I guess you are not familiar with Japanese English. Yeah, Japanese English is a different accent of Taiwanese English. So yeah, I think it's good to. I think it's a good opportunity to hear the different accent of English. Yeah. Probably 3 years later or 4 years later, I think most of you will attend the international conference. Then, where lots of people come to the conference from variety of countries, and they each have a different accent. And I still struggle to understand what they say. Yeah. So yes, so you need some experience to hear and communicate with foreign people in English, and then try to learn how to adapt your English hearing ability. Anyway, so the supervised learning, maybe he will explain later.
No, I think you can explain.
Oh, yeah. So the supervised learning is a learning for a problem for which the correct answer that is called the teaching data is given. And the learning model, this is a learning model, iteratively modifies the internal parameters. The model has the internal parameters. Maybe some of them know the neural network. Have you teach that?
Not yet, but I think maybe few students, the third or the fourth year student.
Okay.
But because most students are undergraduate the first year.
Okay. So the model means that is a kind of the function from the input to output. So the function receives some input and then generates some output. Right? Then the function, please assume some function, and the function has some variables, right? So we call the parameters. And using the supervised learning, the model will receive the correct answer. Then try to tune the model parameters to output the correct answer. Now this is a supervised learning. Okay. And the reinforcement learning is very similar to the supervised learning, but the model here I put the learner. Both of the classroom. You can think this is a model of that. And the learner will receive not the correct answer. Instead, the model receives the reward. The reward means good or bad. So the learner receives some input and then generate the output. And if this output is correct, then this learner receives the reward. But in the case, if the learner output generates incorrect output, then this learner receives penalty and then change internal parameters. So this is a reinforcement learning. It is a kind of the similar learning learning ability like the animals. Animals receive the reward, not the correct answers. And also you also learn something based on this. Some subject you know about the correct answer and think about how to do that. But some subject you receive some score or something, not the correct answer. Then maybe Professor Lee said you are a good student, but you don't know which sense. But at least you receive the good from him. Then okay, that maybe this behavior is good for him. Okay, so improve more. This is a type of reinforcement.
And so it's okay for student to photo with this one. Yes. 所以大家都可以拍照，你把它拍照下来，然后你丢给这个记录，它就会跟着来，它就可以传。像这种基本的概念，大家可以解释看看。老师刚去维也纳也是一样，很多就拍照下来，然后丢进去，然后它就可以帮你弹出。可是你还要修，你一定要等要去修，要去看。
哦 ，OK。
这一页你要解的很多个，我的习惯是这样，我去维也纳也是一样，我讲，比如说会讲1个小时的演讲，觉得太多了，我就挑几个部分，重点，我觉得重点来写 ，OK。
Okay, so the another type of the machine learning is the unsupervised learning. The learning for problems for which the correct answer is not given. Correct answer and also the reward and penalty are not given. Then the model receives some input and generates some output. And here, unsupervised learning, the model tries to make the internal state stable. Maybe it's difficult to understand, but later maybe you know that. And since supervised learning is the name indicates is the supervised learning, but it's same. Same means it's a hybrid of the supervised learning and unsupervised learning. All right. So the model receives the partial answer, then choose the internal parameter. So this is the supervised learning. In our daily life, totally this learning appears everywhere. You receive some correct answer or result, and sometimes not. But you learn continuously. Right? Then I explained the three types of the machine learning tasks. And the first one is a regression. Regression is the problem of learning continuous function that returns real value for a given input. So let's assume the two-dimensional space, and there are some data points, right? Then, sorry. So this is a problem on the one-dimensional space, and the input is on the x-axis, and the output is the y-axis, right? And first we had some data point, in this case 6 points, and around the relationship between the input and the output. So the relationship between x and y, right? So assume the function, the fx equal y. So maybe the y equal fx, right? And I try to tune the parameters in function f. Then predict the output for unseen input. So using the known data point, the function is done like this. Then the function will receive the unknown patterns and predict the output using the round function. So this is a regression problem. Yeah, I should say regression task, right? Okay. So the second task is classification. The problem of assigning an input to one of the given classes. So assume this is a two-dimensional space. So there's a two things. For example, there are weight and height and so on. Then each pattern has a class. So in the case of the height and weight, the maybe class is healthy or unhealthy or normal or something. Right? Then the model run the relationship using these patterns. And once the model receives the new input, they predict the class. So this is a classification task. And third one, the clustering. The problem of sorting input of similar nature. Assume the patterns like this. The pattern, pattern in the two-dimensional space. Then in this task, the algorithm tries to find some group. So maybe the algorithm finds these groups or these groups. Right? Now this is the clustering. Now this is also based on the unsupervised learning. We don't tell the model how to what group is good or not. Just the learner try to make a group based on the internal state. All right? Understand something? It's okay.
有听懂吗？刚刚讲了一个是分类嘛，就分几类、分几群。那一个是回归，就是说预测，预测明天会下雨，预测会不会有台风，那个预测那个什么路径，什么台湾的路径、美国的路径、日本的路径，有没有？一个是 regression 就回归，你找出一个函数。那刚刚讲的就是那个分类，就分几群嘛，把资料分2群、分3群，找到一个函数。那所以 model 这个function 老师讲过嘛，就是很多人 接下来那个Nojima老师就要讲演化式计算，就是 GA 跟 PSO， 你们不是去做微调嘛？上一次他就要讲这个，这样 OK 吗 ？OK 好 ，OK 好。
So if you don't understand, then please ask.
And ask me. 那请你记住，这里有个积分的方程，对，也有时候我有考试的派。
Yeah, yes. So next topic is evolution computation. So everyone don't know, except for the student of the Professor Lee's laboratory. Okay, so what is this? So the evolution computation is derived from the idea from natural evolution. Speaking of probably the term natural evolution reminds you this type of figure, right? Starting from A and then through the evolution and our body is obtained, right? But this figure is wrong. The correct figure is like this. So there are several individuals in a population in one generation. So I wrote that there exist variations among individuals in a population. So assume this circle is a population in one generation, right? Then some individual has a strong, some individual are weak, right? Then those who are better adapted to their environment, it means the strong individual have a greater chance of surviving the breeding and passing their genetic information to the next generation. Right? So weak individual will die very soon. Then use a chance to pass on the gene to next generation. But a strong individual have a chance. They live longer than the other and have a chance to have a baby. Right? Then in the next generation, the individual receive some good information, good genetic information from previous generation. So we expected that each individual has the strong, stronger than the previous individuals. Right? So then defeated this process. So finally, this is not the final. The evolution is continuously, but until now, we have this body to live this environment. So because this type of body is good to live in our environment. So the important point is the environment. So the animal, the good individual in the facing environment is a key. Then this is the example of the desire of evolution, and some of them, some animals have a very strange face, very strange shape, and sometimes a very strange behavior. But those forms and behaviors are well adapted to their environment. Some animals are living in the forest, some animals living in the deep sea, or some animal is wet condition or something, right? So each animal get the body, the well adapted body and the behavior. But it's totally depends on the environment. Right? But you have to know that the animal does not try to improve their body. The individual don't do that. But only how to say that? some individual has other well adapted the body and behavior by accident. Then those individuals living longer than the other, and the chance to give good information to the next individuals. So this is a natural evolution. So this is not the evolution competition, but the evolution competition derived from this idea. So
I explain. OK， 你就解释。所以刚刚那个 Yusuke 老师解释的就是说自然界的现象，比如说 Yusuke 老师跟我说台湾现在是夏天，你看我是穿这样，他穿这样，那可是等一下他要去韩国的时候，韩国大概10度，他们现在大阪大概10度，那我们1月去的时候可能会下雪，就是大家要跟环境做互动，而且是自然演化。所以你看那个动物从狒狒，我们现在人会站着嘛，以前是那个从猴子啊，然后狒狒，然后动物也是一样。那这个是自然界的现象，我们用的 GA 跟 TSO 原理，IP 也就是这样的，我们就观察动物自然界的现象，小鸟啊，动物啊，各种不同的动物。那接下来就要讲数学了，就是由那些现象来用数学式来表示，数学式表示完就要写程式了，然后就用电脑帮我们算，这样 ，OK？
Alright. So what is evolution competition? Now you have a problem. You want to solve, right? You will have a problem you want to solve, right? That's sooner or later. Then first we generate the algorithm generate the candidate solutions randomly. In general, we generate the random solutions first. Then each solution represented by like this, using some variables, and the variables represent the solution. All right. Later I will give some more example, but the variables is similar to the gene chromosome information. Whether you had the class in high school, so you know about the evolution. It's evolution based on the chromosome, right? So this is it's like a chromosome, and also that we say chromosome in evolution competition. And then sorry, this is a population, and this is the solution, one of the solution in the population. All right. Then we define the thickness function for the problem you want to solve. Then check how much each generated solution is adapted to the thickness function. Then the algorithm choose the better solutions first, and make a new solution using a partial information from the parent's solution. Then make a new offspring populations, and calculate the thickness function again, and take a better solutions, and make a new solutions, and repeat. This process repeated. Then finally we will get the solution with very high thickness. It means the optimal solution for the problem you want to solve. So this is the idea of evolution computation. Got it? 有听懂吗？有 ，OK。Yeah, if you know the IDP. Then you know about it.
对啊，你们有出国，其实我就跟校长讲，国外的老师比较喜欢跟别人互动，讲，然后看有没有听懂。那我们补习班就一直教，大家一直抄。那我现在开始解题。那我们是希望说大家知道基本的概念，所以他基本概念讲的很仔细。那我们希望说大家可以把这个概念写到你的那个期中考试的那个重要概念。从第1代、第2代到第100代嘛，人类也是这样几千年演化，慢慢越来越厉害。AI 也是一样啊，写程式也是一样，就很多事情都是慢慢这样演化的。OK，
Yes. So I have 24 minutes. I don't think I can finish all the topic, but that's right. Yeah, I will be very happy if you understand at least the concept of machine learning and the concept of evolution computation. And the next time, then maybe you will understand the evolution of machine learning. Okay? So the evolution computation, this is a general procedure. It's a very simple. And the first and the most important point, one of the most important points is that define the chromosome representation. We call the solution representation. How the solution are represented. And also the fitness function or objective functions. So these 2 points are very important. So I will explain that. So maybe you don't know that, but I give you some simple example. It's an operational research problem. So they don't know that something.
I think for the freshman maybe they don't know, but for the some the third year student they understand.就是演算法你们大三的时候就会修这背包问题，你要把什么东西要放到你的背包上最后，比如说你们背包装了很多东西，很重的东西，它的也是一样，到这边人家送这个礼物，那边送那个礼物，然后最后你们出国的时候，很多老师就把东西放在旁边，因为带不懂，听懂我意思？就是要把最重要的东西带走，这是背包问题。那这个如果是大三、大四的同学，应该都会知道，这是很有名的一个演算法。如果推销员问题，比如你从新竹，然后到台中，然后到台南，你要走最短路径，然后把油钱最少或那个车钱最少，然后你要赚最多。推销员你要去很多不同的城市推销你的东西嘛。那这个是演算法的问题。I think the freshmen maybe they can understand. Not yet.
No, they can understand.
They can understand. Okay.
Yeah, of course, yes.
Okay.
But let me skip this side. He already explained. Right? Yes, those are it's kind of benchmark problems. We normally use this type of problem for algorithm development. And this is the combinatorial optimization problems. Which items should be put in the knapsack. And this is the permutation problem. How we visit, which city we should visit first and second, and so on and so on. And these are different problems. And for this problem, usually we use a binary strings to represent the solution. So 1 represents the include this item, and 0 means exclude this item. So 1 0 1 0 0 1 1 0 means you taking these items and putting the knapsack. So this is a chromosome. All right. So in this case, the solution is represented by the order of the distinct phase. And algorithm try to change these numbers to find the best combination of the selected items in this case. And the algorithm try to change the order to minimize the total length. And also, in some problems, I say some problems, and we use real number strings like 0.5, 0.1, and so on. Right? So there are various types of solution representations, and also evolutionary computation can use the mixture of them. Some part of the chromosome is represented by binary, and the other remaining part can be represented by the permutation or real number strings. So it is possible. So it means the evolution computation solves the variety of problems at the same time. And objective function definition is also important. If you have a problem, you have to define which solution is how much better. So it's totally depend on the user. The user, if you want to, okay, this is the one example, robot navigation. The robot car is here, and the goal point here. Then maybe you can you define the object function like this, minimize the travel time to the goal. Yes, and if you want to consider the collision of the car with some obstacles, then you can add some the term like this, and so on and so on. So you can really define the objective function, and evolution computation find the better solution based on the objective function. Then also we can directly evaluate solutions generated by algorithm. So this is also interesting point of the evolution computation. So evolution computation make some promising solutions, and then the human user evaluate. Oh, this is good solution, or this is not a bad solution. Then based on those evaluations, algorithm try to make different solutions. Yeah, this is a video from maybe more than 20 years ago. When I was a PhD student, I tried to optimize the behavior of the human arm to pass something to the user. So maybe you think it's easy, but it's totally depends on the user. There are some user comfortable like this motion, right? But some user want to like this motion, and maybe not. But it's totally depends on the user, right? So the evolution computation can cooperate with human user. This is an interesting point. Right? And yeah, briefly explain the genetic operations. The genetic operation needs to change, needs to pass the good information to next operation. Basically, there are two operations, crossover and mutation. Crossover means the partial information is passed to the next operation. This is the most representative crossover operation. It's called the one-point crossover. We specify the cutting point first, then change the chromosome information and make a new population. So the new population, this population, the offspring A, has the first part of the parent A and the second part of the parent B. Right? So assume your father and mother, then you and your sister or brother. Then also the mutation is I said, change some the small part of the chromosome. Like this is the most representative mutation operation for binary string. It calls a bit mutation. This operation selects the gene position randomly and change 0 to 1 and 1 to 0. Then make a new individual. Right? But of course, the appropriate genetic operations strongly depend on the solution representations. But these are very frequently used operations for binary strings, but there are lots of operations for permutation or real number strings. All right. Now this is an example. Yeah, you can visit this web page, and the objective function defines the maximum distance plus average speed. It means the robot try to move further and with good speed. But we don't know what type of behavior, what kind of shape is useful, is good for the environment. The environment is very bumpy. There are lots of upside down the environment, and the body is trying to move from starting point to the far away. And in this problem, there are several design variables. All of them, I think all of them are represented by real number strings. So the lower is 0.1, 0.9, 0.5, and so on. So that kind of program used in this problem. Then the first, the solution of a number of solutions are generated randomly, and some solutions are very good. Well, but the shape is very strange. And the important point is that we don't know the appropriate shape of the body for this environment. Yeah, because we don't have experience for this environment, so we cannot design the appropriate design. But the evolution computation try to find the appropriate shape, the body of the body through the evolution. Yeah, the different shape that works well than the one in the previous generations. So, this indicates the fitness function value, and yeah, the latter is better. So yes, so gradually improve the shape of body. Yeah, you can visit this web page, and you can change some variables. Then you can see how those parameters affect the evolution. This is very fun. Yeah, I recommend it. And maybe some of you know, okay, so evolution computation can be used for some toy problems, but not. The evolution computation can be used for, of course, real world optimization problems. You know, this is this one, the Shinkansen. Yeah. And evolution computation was used for design of front nodes of the blue plan. This is the special type of the number of type is N700. So this shape is very strange. It's like this. I think a human designer cannot define this type of shape, but the evolution computation can define this type of shape. Of course, the user, the designer, define the several objective functions, and the algorithm try to find this shape. And this is another example. The evolution computation optimize the shape of main wing. So the evolution computation can be used for various applications, various real-world applications. All right. So if you are interested in evolution computation, I strongly recommend to visit this web page, and then you will know how much important to choose the appropriate representation and also the appropriate agentic operations. And maybe a few of you know about this problem. This is also the kind of representative OR problems that it calls N queens problem. The queens, each queen are okay. Let's skip that explanation. But anyway, I recommend this service. You can interactively understand how it works of each operations. Oh, So you get some idea of evolution computation?
有没有听懂？刚刚那个新干线哦，它那个车那个形状，就是用演化式计算把它跑出来，就是那个形状。然后还有飞机有没有那个机翼那个长度，也是用演化式计算跑出来。因为人到底要去设计什么比较好？那当然还有游戏啦，比如说像刚刚玩那个 DIY 玩很多东西。那我那个很多website上面都可以去调参数，然后你就可以去玩。大家可以有兴趣可以去试看看。OK，maybe 等一下把我记好。
Yeah, I have 8 minutes.
8 minutes, yeah.
8 minutes. Yeah, almost impossible to finish all the slides. But you will get the slide, and then next time you can see. Maybe I will explain the same thing, then you can refresh your memory. Yeah. Okay. So what is evolutionary machine learning? This is new for you. And evolutionary machine learning is a hybridization technique between machine learning and evolutionary computation for tasks including the classification, regression, the clustering, the reinforcement learning, and the optimization. Right? I already explained some machine learning tasks in the concept of evolutionary computation. So now you have please think about that. Then I will quickly explain the various branch of the some branch of the evolution machine learning. But we can roughly divide evolutionary machine learning branch into two. One is EC on the top of ML. So EC try to improve the machine learning method. And the other one is machine learning is on the top of EC. So machine learning can have the optimization by evolution computation. So there are two categories. And in this slide, I only include the first part, the EC on the top of machine learning. Okay. And the first one is the genetic-based machine learning. It's okay. The genetic machine learning is the if-then rule-based system design approach for classification and regulation and reinforcement learning. So the model is represented by a number of groups, and the evolutionary computation try to improve the groups. This is genetic-based machine learning. Oh, I skip this. Oh yeah. Okay. So next one is the evolution of fuzzy systems. So you explain the fuzzy system. Did you explain fuzzy system? No, not yet.
Yes, and they already designed some fuzzy inference rule.
Okay.
And they also use the tool to design the quantum fuzzy inference engine.
Okay. So good.
Quantum CI, quantum computational intelligence.
So the fuzzy system is also the rule-based system, and but the difference is we can assign the linguistic level, like a wide, medium, high, or short, medium, tall, or something, right? Then the rule can be represented by if the height is tall and the weight is heavy, then unhealthy or something, right? So this kind of expression can be possible using the fuzzy system. Then the evolution computation can optimize the fuzzy system. For example, the evolution computation, they're using a binary string, optimize the selection of rules. We can generate a large number of rules from data, but some of them are conflicted, or some of them are not necessary. Then the evolution computation select important rules and then make a small compact rule set. It is possible. And also the evolution computation choose important features in rule-wise, and also the evolution computation change the membership function, the selection of membership functions, and even shape of membership function can be tuned, can be optimized by evolution computation. Oh, 3 minutes. I think I should finish now.
Yeah, I think because later I will invite all students to take photo with the dean of international office in the first floor. Because next week my department will have education assessment in Taiwan. 就等一下我们要邀请大家帮忙到自公司那边，我们要拍一张照，因为下一站我们是实践。那我们国际化这边是要这样看的。OK， 刚好有机会可以邀请到国外的教授过来。等下国际长也会过来，国际长11点半就会过来，然后副总再赶过来这边。我们要
Let me explain one more branch. Maybe you will be interested in neural network because the neural network is kind of the group. Yeah, you know, the deep learning, deep learning, and also the large language model. All of them are based on the neural network. So let me explain the evolution of neural network. So neural network plays a great role in the current AI boom, as I said. But there are a variety of topologies having proposed so far. But this is a good thing and a bad thing. And the weak point of neural network is like this. The continuous and differential error function is necessary. And getting trapped in local optima by gradient based learning. And also the appropriate structure design is necessary. Right? Then we use some strong point of evolution computation. The evolution computation can be used as a gradient-free optimizer and avoid the local optima using the population and the simultaneous optimization of weight and structure. So this is a good point. So we use a good point of evolution computation to improve the weak point of neural network. So this is the original neural network. Maybe easy to understand. The input here and the output here. And each node will receive the various layer and then the make output, right? So usually this structure is designed by hand. The human user defines this network. But sometimes the network is too big or too small for problems you want to solve. Right? So the appropriate structure, appropriate proposed is based on the problem you want to solve. Then network weight is usually tuned by using the gradient-based optimizers. Then the evolution computation, as I said, can be used to optimize the weight vector directly. They are using the gradient-free optimizers. And also, the evolution computation optimize hyperparameters of network. Hyperparameter means how many layers the neural network has, or how many nodes each layer has. So we can optimize this structure by using evolution computation. And also, we can optimize at the same time the weight and structure. All right. So I skip and then yeah. Some of you are interested in the large language model. Of course, the evolution computation is used for optimization of large language model as well. So you can visit the Sakana AI webpage and then find this type of article, the evolutionary model match. This method is matched some part of the large language model to adapt to the problem you are focusing on. All right. So this is the final slide. The take-home message, two take-home messages. The evolution computation assist machine learning method to enhance their ability, the prediction modeling learning classroom, and the candidate solution representation is a key to implement evolution computation. And I give you the assignment. This is homework, but please think now after my talk, right? Find the machine learning path around you. Around you, there are many machine learning paths. Then just think about the appropriate evolutionary machine learning technique, or think about how to implement, how to use evolution computation for those machine learning tasks, right? And then please ask him. I think, yeah, he will. I will talk about. Yeah. So please come to him and then explain. I think the evolution computation can be used for blah blah blah. Then if he think, oh, this is a good answer, then you can get the snack. You know the hockey, yes, yeah, hockey. But the limited edition, it's a winter edition. So maybe I think you cannot get this limited edition because the Tainan has no winter. This is a winter.
你们知道这个吗？你们可能都知道，我都不知道。那个学长不是有给3个主题吗？有没有？你们就选一个主题啊。他说明已经有 assign 了，明天你们要做的主题，有没有
？So each box has two. So only four students can get.
Maybe student can keep up.
Yeah, but
你们主题啊。
He don't think that your answer is good. Then he takes this. Right? So the please see.
有没有？现在有没有？不然我们等一下就要在这拍照了。
没有的话就我掉了。
对啊，举手啊！
举手。我们的主题啊，那个英文快点。
对啊，学长不是有给你们主题了吗？
拿3个，这3个。
啊，这个好了。好。
有 test。有马上就你 test。
对啊，就 homework 啊，就是你学长不是有给你们什么环境啊，什么美食啊，什么旅游啊，就什么我不知道3个主题嘛，明天要做的啊，来赶快举手看，用英文讲，我们用中文讲，师傅帮你们翻译也可以，或学长帮你们翻译。
I think that they need some time. So that we will go to downstairs and then take a picture.
Okay.
Then you can
say conclusion. 现在有没有？不然我们就要下去了。用英文讲那个很简单啊，不是有3个主题，就明天要做的。来，你可以讲这个对吧？有没有？来，那你跟我讲。这样举手，你要举手。就是你可以用那个EC，有它是计算，我们不是有用 PSO 用 GA 吗？有没有？它不是有用模糊系统吗？你要举手。对，你随便讲一个就好。
The girl has the machine learning test.
那你就饼干可以吃了。这老师特别从日本大阪带过来的。
Machine learning test is intelligent travel about like how to find the site which the distance and the data or some how is your input variable.
And distance and how much it costs.
Distance, cost, and comments.
Comments.
translation. It's okay.
It's okay. Yeah, it's okay. Yes, she gave us a very good point. Yeah, I already explained, but we can define the multiple objectives and we can optimize those objectives at the same time. Yes,
one point.
Let's choose.
Okay.
About what input value about? The key will evaluate. So that yeah, you can answer in Chinese, Taiwanese. So that I don't care about that.
你可以用哪一个？I will translate.
No. I think that we have to go down.
Oh yes.
Oh yes. Okay. 价格、距离跟主价。
价格 cost
cost difference and the comment about the restaurant.
有没有说一下？就是比如说餐厅的菜的
你菜的喜爱程度吧
like and delicious like this. It's okay. Okay.
Only two available.
我
们等下就下。
我们这边拍一张好不好？
我们现在这边拍照。
我们那个是不是可以把它放到第一页？Maybe the first page, then here one photo, then the first photo. 请大家先到前面来，好不好？我们这边拍一张照，就是今天那个Yusuke 老师有来这边演讲，快点，有些人都在前面，那等一下，因为国际长已经到了，我们等一下请大家帮忙上去看那边。来，东西可以先放在座位上，没关系。东西先放着，好不好？先放在座位上。等一下在那个，因为我们等一下要去德光中学，所以时间很赶。你们有些可以站这边，有些可以站前面这边。maybe 东西要放好，不要大家去当地了。那当有些蹲前面好不好？那因为这样不然站着会，因为这边可以他的名字。那其他有些蹲前面，那曹娟你赶快跟大家讲，前面这边。有些跟前面，有些你不到后面跑不到。要不要关？要不要开灯？还是开灯？哦，我的脸会照到。我就做了啊！因为刚刚那边有一个群，是不是那里游戏？对。新闻上可以看得进去吗？这一场位置，口罩可以拿下来，没关系，好不好？挡到，如果挡到就往前，好不好？
好，那我这边呢，1、2、3，下一个。
在最后一张。
好，
谢谢。那接下来我们要请大家帮忙到自动一楼，谢谢。